How do we find for the equations of a line given 2 points? So we know that 2 points determine a line, which means that if you are given, for example, this Cartesian plane, and then we look for, or we are given 2 points, let's say for instance, -3, 5, and the other one is a point 2, -1. So if we are going to plot these points in our Cartesian plane, we will have -3, 5, which is located in our second quadrant. And also, so we have here 3 for the x and then 5 for the y. So that is the point here. So we can name this as our point A. And the other one, let's name that as our point B, the point 2, -1. So we have a positive and a negative for the y. That means this is located in the fourth quadrant. So 2 for the x and -1 for the y. So that is this point. So if we decide to combine this or connect these 2 points, we are forming a line. And if we want to look for the equation of this line, it is very much possible making use of our 2-point form. So we can see the formula here, which is y minus y sub 1 is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, quantity x minus x sub 1. Remember, the y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 is actually the slope of the line. So the change in y all over the change in x. So how are we going to do it? So the variable that will stay here will be the variable y. So y will stay as a variable. So we will now have y minus, we can choose whether our point 1 is the point -3, 5 and the 2, 1. Anyway, that will not change the result that we are expecting to get. So when we will decide that this will be the x sub 1, y sub 1, that will be the terms that you have to write. Okay, so instead of writing now your y sub 1, we are going to substitute it with the value of your y sub 1, which is now equal to 5. So y minus 5 is equal to the slope of the line. Okay, so since we have this point A as our x sub 1, y sub 1, we will now have our point B as our x sub 2, y sub 2. So substituting it in our formula, we have -1 as our y sub 2. So we simply have -1. And then again, the value of your y sub 1 is 5. So there you have it, -5 all over. So x sub 2 is 2 also. So we have here 2. And we have to subtract x sub 1. So minus negative. So there should be a change in the sign or the operation that you have there, because minus the -3 would mean plus 3. And again, we will take your x as the variable. So x minus your x sub 1, and that is equal to -3. So again, there will be a change. Instead of having -3, that will now become +3. Okay. So again, the rule is if you are given 2 points, you let your first point as your x sub 1, y sub 1, and the second point as your x sub 2, y sub 2. And then after that, you substitute it to the 2-point form. After doing that, we just have to simplify. So y minus 5, we just have to bring that down. So y minus 5 is equal to, let's have the slope first. You have -1 minus 5, so that will result to -6. And 2 plus 3 is equivalent to 5. And of course, we just have also to copy the x plus 3. Usually, we don't want to be working with fraction. Like in this case, you have 5 as the denominator, -6 over 5. So what are we going to do here? We just have to multiply this whole thing, okay, both the left side and the right side of the equation with the existing denominator. So we have a 5 here. We need to multiply now 5 to the left side. And to maintain the equality, you have to multiply also on the right side. So if you are going to do that now, this will be distributed. So 5 times y, we will have 5y. 5 times the -5, that is -25. Now you will notice here that this will already be cancelled. So 5 and 5, so 5 divided by 5 will already be cancelled because that will give you a result of 1. Okay, so therefore what will be left is just the -6, and that has to be distributed to your x plus 3 or the quantity x plus 3. So this will now give us a result of -6 times x is -6x, and the -6 with the 3 is -18. Now let's remember, for the equation of the line, you have the standard, what we call the standard form for the equation of a line, which is ax plus by is equal to c. So this is your standard equation of your line. Again, the a is the numerical coefficient of your x, b refers to the numerical coefficient of your y, and c is the constant. So we are going to follow that form. Okay, so this simply means that the -6x here will need to go to the left side of the equation. So there is a need for us to add 6x on this side, so that it will now become -6x plus 6x is equal to 0. So you have to add 6x on this side. So that means we have now 6x. 5y will have to stay on this side. So we just have to add 5y. As you notice, there is no existing sign here before the term 5y, but we know that that is understood to be positive. And then we now combine the -18, and for this to be eliminated on this side, there is a need for us to add 25. Therefore, the answer that we will be getting here is -18 plus 25 is equal to 7. So this is now the equation of the line. Okay, this is now the equation of the line that contains the points -3, 5, and 2, -1. Now, how can we make sure that we are correct? So we can do what we call the checking, and we can do the checking by simple substitution. Okay, so for example, our point A, the first point that we have or we considered here is the -3, 5. So what are we going to do? Remember that if you have an ordered pair, this actually refers to your x, while the second entry is the y. And we can do that here. So for the checking, we simply have to substitute now 6 multiplied by the x. So here we have -3, and we can add that to, we have 5y. So 5 multiplied by the y here, which is also equivalent to 5. And we are going to check, okay, whether this one is really equivalent to 7. So check, we have 6 times -3, that is -18, and then we have 5 times 5, that is equivalent to 25. And applying your rules on integers, this is -18 plus 25. They have the same sign, so we have to subtract them. So the answer is 7. So subtract 25 and 18, that is 7, and we take the sign of the number with the bigger absolute value. So that is 25, which happens to be positive. So therefore, 7 is equal to 7. Okay, and that must also be true with the second point. So for the second point, which is now your point D, we have 2, -1. So this must also be satisfied. So how? Again, we go back to the equation that we obtained, 6x. So 6 multiplied by the value of x that we have, and that is 6 times 2. And then plus 5y, or 5 multiplied by y, which is in this case -1. So this will now be equated to 7. So let's find out. 6 and 2 is equal to 12. So 12, and we have 5 with the -1 is -5 multiplied. You have now a plus -5, so that will turn into -5. And it's so obvious now that 12 minus 5 is equal to 7. So therefore, the solution or the equation is also satisfied. So the equation of the line, okay, that passes through the points -3, 5 and 2, -1, which is illustrated in this Cartesian plane, is 6x plus 5y is equal to 7.